Welcome to a beautiful Tuesday morning. Futini namhlanje uthobile namhlanje zabe ngisizang with acids and bases and show you guys how ionization of water actually occurs.
How do we show the ionization of water?
A beautiful warm welcome to you guys. Igama lami nguThobile and the science guru by profession. So namhlanje we're going to be doing more on acids and bases. So I'm going to learn a question yami yokuqala namhlanje, and the first learner question goes, how do we show the ionization of water? So one major important thing, guys, is how do we actually get to the ionization of water? If we actually take a little recap, last week's in with the three different theorists and the theories on how they distinguish between acids and bases. We were dealing with the Arrhenius theory, with Lewis-Bronsted theory, and so forth. So all of them had different ways on how they actually distinguish if something was an acid or a base. Some of them were like, no, an acid will form an H+, or no, it will donate, or no, it'll form an hydroxide or hydronium. So now with the ionization of water, water actually has both. It has an H3O+ and it has an OH-. So it either acts as an acid or as a base. So before you can actually learn with the ionization of water, what are the three theories, and with the three theorists, rather, with the three theories actually differentiate or distinguish between acids and bases? We'll just figure with the ionization of water. Because let's figure like ionization of water, we actually use this type of method to actually calculate the pH of a solution. And how do you actually then calculate the pH of a solution? And something that's I'm going to give you guys a little bit of tips of how you actually, the things that you actually need to know when you're preparing for your tests and exams and so forth. And then we do some examples. Okay, if you were given an example or if you were given a scenario, how do you actually go about actually answering it? So with the ionization of water, water is an amorpholite. So think of an amphibian. And all that stuff. So it acts as both, though it's a reptile, right? But it falls more to being an amphibian. So and it's all healthy for us and so forth, but water can act as an acid and as a base. That's why it. And if you can look down here, why it actually acts as that? Because it forms the H3+ and it forms the HO-. And how these two forms with manjag? Okay, so I want with manjag of sinamanzi, which is H2O. Now we've got an H2O. Then we have one of these hydrogens, so it will break up then to being an H+ and then to being an OH-. So this hydrogen will then fall into this to form the H3O and the OH-. And then with what we have learned last week, no, but you only identify an acid and a base depending on what actually forms. So if this has formed, then we can either say it's an acid or a base, depending on what theory or what theorists you're actually supporting. Or if I see the OH-, that means it falls, it can be then an acid or a base. But in this case, amanzi actually forms both of them. So make sure that you actually know what's happening here. What they like doing, manpala ama exam, okay, we know that water is an amorpholite. Okay, with this, say why, and use a diagram to show us how water can do this. Or they might say, okay, water is this, but then show a diagram how water can then be said to being an acid or a base. Right, so you need to know how to draw this structure and how to explain it. Explaining it meaning, we had lost the hydrogen there, and this is what had formed on this side, and so forth. So be very, very careful with how to actually do this. Something else to add, guys. This is now what we learn in grade 10. When you're working with anything in chemistry, you first things first, is your equation actually balanced? Because if your equation is not balanced, you will actually not get the correct answer, which is very, very important, because when we were working with velocity and momentum and all that stuff, we worked with meters per second, we worked with distance, and so forth. So in this case, we work with moles and volume and all that stuff. So everything needs to correspond. No mama she puts 10 cups of flour with 1 spoon of baking powder. She can't put 15 cups of flour and then put half a teaspoon of baking powder. Expect cupcakes. No. Everything has to be sequential. So make sure that your equation is balanced so that you actually get the correct results. So in this case, the equilibrium lies far to the left, and the equilibrium constant for water is given by this. So be very, very careful and be sure that you actually put this together like that. And then you use these brackets. So in grade 3 we learned no. If we put the round brackets, it symbolizes multiplication. In this case, physical science is a language on its own. And scientists are the laziest people who hate writing. So instead of writing the whole word concentration down, we just put these brackets and then we move on. So make sure that you don't use the round brackets, guys. That is incorrect. You use the string brackets. Because I know what you're talking about, and you give them a surprise for once, right? I'm talking about the concentration of a hydroxide or a hydronium from this equation, and everything follows sequentially. And then the Kw stands for the ionization constant of water. And then we have to put it to 1 times 10 to the power of negative 14. And this is because, taking a little recap from last week. Now, so last week's funded a little bit about pH, where we learned the pH scale ranges from a 0 all the way to a 14, where from 1 to a 6.9 is more acidic, and from 7.1 all the way to 14 is more basic. So because water forms both, we have to say times 10 to the negative 14. And then that's how we then start calculating pH using this type of equations. Nah? So therefore we know that we have our H3 plus and our OH minus, which we can then equate to this. So Lana Manjaga, if you are then working with this, also plug in whatever concentration you have with that, or if you were given this one, then you'll plug in whatever concentration using this type of formula and equation. Eh? So now with pure water, then this is what you'll then use. And be very, very careful that you use the correct SI unit. In mistaken time, when you're working with, let's say, velocity, remember we were using meters per second. With momentum, we use kg per meter per second and so forth. So when we get to this topic of acids and bases, we work with concentration and stuff like that. So we need to indicate, now I'm working with concentration, it's mole per cubic decimeter. I can't, for example, say Mbuyi weighs 18 cows, Mbuyi weighs 18, Mbuyi has 18 what? So you need to show your examiner that you know what you're talking about. Because if your SI unit is then correct, it means good magic, you actually know what you're talking about, and there's a fair chance that everything else might be correct. And the whole point of one with magic, do you know what you're talking about? Are you able to read the scenario when they're telling you an acid and a base and you must find the volume and whatever? Because the SI unit also determines everything also. So make sure that you use the correct SI unit. And then you'll have your acidic solution and then your basic solution. And with these two, if you are given a scenario, what is important by referring back to this, if I'm given a scenario, I'm saying, okay, so we need to calculate whether HCl is more acidic or basic in water, and then you have to find your answer. If something is more basic, it will then fall to a certain range of the pH scale. If something is more basic then or acidic, it will form in whatever scale. So make sure that you actually are very comfortable with this, because by the time we manage, okay, if Tobile has a pH scale of 6.75, where does it range and why? Then you can refer back to this. No. But according to this, it shows that I must do this. So make sure that you're very comfortable to know when is it smaller than, bigger than, and so forth. So now, the pH of a solution will be an indication of how acidic or how basic something is. And guys, always use it as a referral or as a reference. Does your final answer correspond with the pH scale? You can't be asked to find how acidic something is and you find something above 7. Then something is incorrect. So make sure that you know how to refer back. Now, something very, very important. You need to know the formula that you need to use. We use the logarithm rules when we're using the pH scale with acids and bases. And he has done a little bit of logarithms. So in this case, you can either use the negative or the positive. Just make sure that you put the correct concentration. So these are the two equations that I would have. Like how we have said, if your pH is 0 to 7, then it's more acidic. And if it's between 7 to 14, it will then be more basic. And 7 means it is a neutral solution. So it's no acidic, no basic. As to begin. So in this case, we have a neutral solution where if something is neutral, it will be equal to 7. However, if it is an acidic solution, then we know that it should then be smaller than 7, but your hydronium will then be greater than 1 times 10 to the negative 7, where your basic solution will be bigger than 7 because it will fall in that pH scale, right? So make sure that you know how to refer back to this. So something that Ekosa Nakona was, you must know the theories that are behind acids and bases, know how to see them, how do you define them, and when you're given a scenario, and they're telling you support the Louis-Bronsted theory. How do you actually support the Louis-Bronsted theory, and what does he actually say? So be very careful on that. Know when an acid releases or a base releases. Know what is a proton donor or a proton acceptor, depending on the theory that you need to support or the theory that you need to work towards. Sometimes what's on with Manjage, using the Arrhenius theory, show how this will then form or how will it dissociate in water. Or using the Louis-Bronsted theory, say how this will happen in water. So make sure that you're very comfortable with this type of section. So let's do a quick example. So here we've got nitric acid, which is a strong acid, and already we know that it dissociates completely. We need to calculate the pH of a solution of the nitric acid with a concentration of 0.5 mole per cubic decimeter. Step number 1, I see that everything is already balanced, and then now I can calculate my pH. So how I calculate pH, I know I'm going to use the H3 plus because this is what had formed. This is what had formed in this case. So I'm going to use this one. And I know that I was given a concentration of 0.5 mole to the cubic decimeter. And then now I'm putting it in order, which is now I'm looking for pH was negative log. And I was working with the hydronium plus. And then I'm going to put the concentration that I was actually given, which was a 0.5. And now if I put this in my calculator, I get 0.3. So now this is now the pH that I have. Number 1, I know that nitric acid is a strong acid, meaning it dissociates completely. Now I need to check, because lama rules la so I need to use those rules, whether it's bigger than, smaller than, or equal to, whether this is correct. If this is my pH scale, and this lies a 14, let's say this is a 7 and this is a 0. So this will then lie somewhere there, which will be 0.3, right? This means more acidic, this will be more neutral, and this will be more basic. So I know that my answer is actually correct because it does fall into the side of it being more acidic, and I know that nitric acid is a strong acid, meaning that it dissociates completely. Another thing, guys, when you're working with one like this, always show your examiner with Manjege. From my equation or my scenario that I was given, I was able to differentiate with Manjege. Did my OH negative or did it H3 plus form? From that, I calculate my concentration. I use my pH based on what I found on the equation sign. And then you put your concentration, you plug that in your calculator, and that's how you then find the pH of a solution. And guys, get it? Got it? Good. That's how then you answer your pH calculations.